Okay, so in this episode I will discuss about some notable earthquakes which have happened recently and one which has happened historically. So the first is the Turkey-Syria earthquake, which happened I think in April 2023. Then the Morocco earthquake, which happened recently in September 2023. And then I'll go back into history and I'll discuss about the 2004 tsunami at the Indian Ocean. And if you know, tsunami is caused by rocking waves as a result of earthquake on the ocean floor. Now, why I'm discussing these three earthquakes is because all of them are caused by different mechanisms. So let me first go to understand what are faults. Well, let me begin by a primer. This is the Earth, alright? Now, if you take a cross section of the Earth like this, then this is the core, this is the mantle, and this is the crust. I've shown a thick crust, it's not that thick. But if you take this crust and if you take the upper portion of the mantle called the asthenosphere, this portion is called the lithosphere. This lithosphere is actually not continuous. So just a minute, let me rub this away. So if I draw the Earth, actually, the lithosphere is not continuous. It is broken into different plates. These plates are called tectonic plates. And they interact with each other. Some plates are pushing against each other. Some plates are pulling apart from each other. Some plates are going beneath the other. Some plates are overriding the other. I mean, a constant interaction is happening. It is this interaction which causes earthquakes, it causes volcanoes, it causes a whole lot of things. But whenever two plates interact, this line between them is the fault line. Alright? So if I represent plates by cuboidal shapes, this is what it should look like. Let me clear this page. So first of all, let me take one plate like this. Alright, this is one tectonic plate, for example. And now let me actually draw an adjacent tectonic plate. Like this. So this is an adjacent tectonic plate. And just for the purpose of simplification or a better visual representation, let me highlight it using different colors. So let me use this color, this. Alright, let me use some color here. So as I can see, both of these plates are interacting with each other. In fact, if I look, they are sliding against each other. So this kind of sliding motion constitutes what is called a strike-slip fault. Alright, and this is exactly what caused the Morocco earthquake, this is exactly what caused the Turkey-Syria earthquake of 2023. But for that, let me make another nearby tectonic plate, like this. And let me use a highlight of another color, say green. And this is also rubbing against this tectonic plate. So there is a rubbing sort of a motion even here. So in the case of the example of Turkey-Syria earthquake that I am discussing, this tectonic plate is the Anatolian plate, alright. This tectonic plate is the Arabian plate, and this tectonic plate is the Eurasian plate. Not just this, I can also draw the fault lines like this. So this is the North African fault, this is the East African fault, and they are all rubbing against each other. So because of this rubbing motion, this earthquake happened, which was the Turkey-Syria earthquake of 2023. There are other types of faults as well. So, for example, if this is a tectonic plate, alright, like this, like this, like this. This is one tectonic plate, and then I draw another tectonic plate. Like this, and let me again highlight them with different colors. So let me use one particular color like this. Like this, and let me use another color for this. So these are two tectonic plates, and again what is happening is that this tectonic plate is like this, and this tectonic plate is like this, and this is, if you look, then this tectonic plate is falling down. All right, that is natural. Why is it natural? Because there is something called gravity. So it is falling down, and because it is falling down in this manner, it is called a normal fault. Let me use another color. This is called a normal fault. Okay, no problem. A lot of earthquakes happen because of this, but this is not the causation of the Morocco earthquake. There's another type of fault. Let me draw. Consider that this is a tectonic plate. All right, like this. Just a second. And then there is another plate like this. Like this. So let me use a different color. Okay, I've become pretty good at drawing after practicing all of this. So that's helpful. Let me use some colors for highlighting. So let me highlight this first, and then let me highlight this one as well. All right, so as you can see that in this case it was going down because of gravity, but here it is going up against gravity. It is going up against gravity, and therefore it is called as a reverse fault, also sometimes called a thrust fault. And this is exactly what happened in the case of Morocco earthquake, because just consider that this is Europe, and I'm not drawing the map very properly, but let's consider this is Europe, or say for that matter, this is Eurasia. Okay, sorry, this is Eurasia, and Ever since the collapse of the Tethys Sea, this Eurasia is there, and we have the African continent as well as the Indian subcontinent, and both of them are colliding against Eurasia. Here you have the formation of the Himalayas as a result of the collision. Here you have the formation of the Atlas Mountains, the Atlas Mountains in Morocco. Then between Spain and France, you have something called the Pyrenees Mountains, and then in Switzerland and all the way through, you have the Alps. And all of this have been formed due to this collision of Africa with Eurasia. And here we have the Himalayas very similarly. So the tectonic plates are colliding, all right? And Atlas Mountain is one hotspot of that collision, all right? So in this case, this one is the African or the Nubian plate, and this one is the Eurasian plate. And specifically within the Eurasian plate, it is the Iberian microplate. You know, the Iberian Peninsula is corresponding to Spain and Portugal, that one. So just imagine that there is a wall, okay, and you're rubbing your hand, you're applying a certain force. Either your hand will be able to break the wall, which does not happen usually, or your hand moves upward because of the vertical component of the force. On very similar lines, this African plate is hitting against the Eurasian plate, not able to break it, so it rises upwards. That's the reason behind this reverse or thrust fault. And this all happened in the High Atlas Mountains in September of 2023. And it happened deep, not just the crust, it happened at some depth in the mantle. It was that deep. Okay, the forces which were responsible are still being studied, but that's how it happened and led to the what? Led to the infamous Morocco earthquake of September 2023. All right, I hope the concept is clear in so far as this is concerned. Next, I want to go discussing about the 2004 Indian Ocean tsunami. Now, I've already told that whenever an earthquake happens, it happens at a certain point in the lithosphere. This point is called the focus or the hypocenter of the earthquake. And then the body waves travel in all directions, you know. The body waves are of two types. Body waves, P and S wave, the primary and the secondary waves. Primary wave moves like this, secondary wave moves like this. And therefore, primary wave is able to pass through solid, able to pass through liquid. But the secondary wave, as soon as liquid is encountered, it is blocked. All right. So if you have this as Earth, you know that the outer core is liquid. So whereas the primary waves will be transmitted throughout the Earth, the secondary waves will travel here, but they will be blocked here. They will be blocked here. Again, they will be traveling here and here. So a shadow zone for secondary waves, shadow zone for S waves will be developed. That's all that you need to know. But apart from that, when this reaches the surface, the point at which it hits the surface is called the epicenter. And from there starts the surface waves. Again, surface waves are of two types, the love waves and the Rayleigh waves. So, if this is the surface of the Earth, okay, if say this is the surface of the Earth, and like this, and the earthquake is propagating in this direction, all right, then the love waves will be like this. That means they are parallel to the ground and also perpendicular to the direction of propagation. So these are love waves. The Rayleigh waves, on the other hand, will be elliptical and perpendicular to the direction. So they will be something like this. They will also rock the ground in a vertical manner. So that is all you need to know about the type of waves. But as soon as if it hits the epicenter, and on the land, above the land, you have something called what? What is this? Ocean. Then of course the ocean water would be sprung up, the waves will be rippled here and there. So, and this will cause something called tsunami. So let me clear this page. So when actually the Indian Ocean earthquake happened, this is the Indian subcontinent, then this is Burma, this is Malay Peninsula, Indochina, then Sri Lanka, some Indian Ocean islands, you have Africa, you have Andaman and Nicobar Islands, you have Sumatra, you have Java, Borneo. I'm not writing, I have told it. So when the so what exactly happened? Let me be absolutely crystal clear. Let me draw the tectonic plates first of all, like this, like this. So this one is the Indian Ocean plate, all right. Then this one I've not drawn perfectly, I think. Yeah, I've not drawn perfectly. Like this. So this one is the Burma plate, this one is the Sunda plate, all right, and this portion is a part of the Sunda plate, but because it is near to the Burma plate, it is called the Burma microplate. All right, now what happens is that the Indian Ocean plate is pushing against this Burma microplate part of the Sunda plate, and it is being subducted. Now what do you mean by subduction? Well, if you have two tectonic plates like this adjacent to each other, T1 and T2, ultimately what will happen? T1 might get subducted beneath T2 with a certain angle theta. This is T1, this is T2. Why? Because of difference in density, temperature, age, etc. And when the subduction happens, this entire inclined plane is a hot spot for the earthquake foci, and this is called the Benioff zone. Not just foci, it will also cause the melting of the underground material, and volcanic material will be released. Magma will come up and you find a lot of volcanoes here. So that's the fact of the matter. So Indian Ocean plate subducting beneath the Burma microplate, and here is where the epicenter lie, and the 2004 tsunami earthquake happened. The ripples went all the way to Africa, of course to Indonesia, Sri Lanka, India, everywhere. So it was disastrous. More than 100,000 people died. I think in the Turkey-Syria earthquake about more than 2,000 people died. Sorry, in the Morocco earthquake more than 2,000 people died. In Turkey-Syria earthquake, I think more than 40,000 people died, but hundreds of thousands of people died in the Indian Ocean 2004 tsunami, which shows how big it was. So we have two concepts actually. One concept is the magnitude of the earthquake. That shows that at the, sorry, I've deleted that. So at the epicenter, which is inside the earth, what was the strength of the earthquake? That is the magnitude. Then it's called the intensity of the earthquake, and this is measured in the so the magnitude is measured in the Richter scale. The intensity is measured, I just forgot, let me check it once. Intensity of earthquake, Mercalli scale. Yeah, it's measured in the Mercalli scale, and that is of course at the surface and related to the damage we just caused at the surface. All right, so the damage can be measured in various ways. Actually, that's all that I wanted to discuss in this video. So meet you all. Keep following Beacon, like, subscribe, and share, and to support. Thank you.